There we go. Okay. Okay. So, what did you guys think of this one?
I liked it.
Bad. It wasn't too bad.
Yeah.
Because it's kind of just been like a lot of repetition. Sorry.
Yeah, expanding what we already learned just a little bit more. You know what I mean? Bless you.
Thank you. I tried to mute it again and then just couldn't get there. I don't know what's going on.
You're sick again?
I hope not. I really hope
I
not.
hope not either.
So, and maybe I missed that. I'm just kind of interested in this because I know we were talking about, like in previous lessons, how like for the t-tests, we always assume, up to now we assume variances are different. Is this a way that we can look at ones where if they're the same?
The way the variances are laid out, is that what you mean?
Yeah, because in the other one we've been doing, like it even says like in the Excel sheet, like assume equal variances, and like it should be no unless told otherwise. And as I was going through the reading, where was it? Because correct me if I'm wrong, the F distribution we're talking about looking at variances, correct, between means, right?
I'm not sure I got my head wrapped around that. I know how to find that number, but I'm not exactly sure what it's referring to. I know that's terrible, isn't it?
Well, yeah, because I mean, right there, if you look at under heading 3, it says ANOVA is a test for equality of several means.
Yeah, so like the way that I understood it was like before we were just kind of dealing with like, because there wasn't so many different variables we were testing, it was easier to just find the means. But with this one, there's a lot more, what was it? Oh, dang it. The ANOVA is dealing with multiple sets of data, so there's more than 2 means, and it's kind of looking at like how different those means are, because they can be matched up with like all kinds of different data sets, if that kind of makes sense. So like there's multiple means that there could be, because like, depending on which ones you're comparing, because you could compare variable 1 to variable 2, variable 1 to variable 3, variable 1 to variable 4. You can compare all of them together, or you can just kind of compare it as one lump kind of group, if that just is a whole kind of entity. That probably didn't make any sense.
No, it didn't. However, there's a section, and I'm jumping around, where it says the largest variance has to be at least 4 times as big as the smallest variance. Did you notice in the video he said 2 times the variance, the smallest variance?
I didn't notice that. No, I remember they were talking about like a way to make sure that it's like normally distributed. Like the test that you have to do is you have to take the lowest variance and multiply it by 4. And if that number is higher than the highest variance, then it's normal distributed.
Yeah. In the video, they use 2 instead of 4. I'm like, oh, I don't like that. So, Jesse, did you answer your question, or did it make sense?
Yeah.
Okay. So then, did you guys go through the preparation assignment okay? Did you guys have any questions?
No, I didn't have any real questions on the prep assignment.
I mean, most of it just comes from entering the data properly.
Yeah, that's kind of the realization I had. Is I was like, I feel like I was like overcomplicating all of the lessons that we'd been doing. But then I was thinking, I was like, really, it's all just like, if you know which hypothesis test you're doing, that's really what the most important thing is. I feel like as long as you know which test you're actually conducting, then it's pretty easy to just pull up the right spreadsheet and just manipulate it based on what the question says. So that's kind of just like what I've been paying attention and trying to do, and it's been going really easy.
Well, that's good.
With that said, I'll probably still like bomb the exam though.
No,
No, I'm just kidding.
Thought I had a question. Oh, I do have a question. When you guys are typing in like bar X, S1, and A, I found the little, a few little symbols in Word, but I can't find like bar X, S to the lower one. How do you guys do that, or how are you finding those symbols?
What I found is the easiest way to get the symbols. You can just copy and paste them from the answer keys on the preparation assignments.
Oh, really?
Yeah,
Okay.
so that's what I do.
That's a good way to do it.
I have an X and then I have a minus sign because I didn't know how else to do it. And then S1, regular one. It's like, wow.
Yeah.
Oh. But I know what it means.
I mean, if you don't want to, type, find the exact character. I mean, you could just literally type like X bar X. I mean, and then
you write it out.
I mean, for lack of a better, more efficient way.
Makes sense.
Yeah, and I mean, with the superscript or subscript, those are actually fairly easy. There's just a button for them in Word.
Really?
But, yeah.
Okay, I'll have
You
to
just
look that
select
up.
the text, and like right where you would select your font, right below that you'll see like an X with like a 2 below it, and then there's 2 above it. So one's called subscript, one's called superscript. Just highlight what you want and click the button. But again, not that it's really necessary. Like for most of the time, like unless
Oh my
it
gosh.
needs, like a technical,
That is awesome.
like manual.
That is fabulous. Thank you so much, Jesse.
Yeah, problem.
Brilliant.
Mm-hmm.
Well, do you guys have any other questions
Really
at all?
cool.
About,
Thank you. Okay. So, no questions. No, not about that. Not about the homework or the preparation assignment.
Should we just go straight into the quiz?
18 questions on the quiz.
Oh.
What's that?
Well, at least we know the answer to the first 2.
I think I am having a hard time with this. You guys are cutting in and out a lot. I think I'm going to sign off and sign back on, okay?
Okay.
Okay.
I'll be back.
Todd, are you hearing me okay?
Yeah, I'm hearing both of you. It's fine.
Yeah, she seemed like she was getting a delay or something, like because she was answering questions like a few seconds after.
Yeah.
So that was kind of weird.
Technology.
Great.
Oh man, there's.
Okay, sucker.
Let's see if that's better. Sorry.
You're good.
Okay,
seems
so you
like it
answered
already.
1 and 2?
Yup. I got false for both of them. I'm actually really curious. Like, would it be marked wrong if you've selected false, or would they give you points for being honest?
I actually no, you actually do. You don't get the points for that, like because like where that last week where I didn't
number
attend
you
Monday, I put false for question 2. You know, like I actively participated. I was like, well, I wasn't there. You know, so I marked false, and no, you don't get the points for it. Yeah.
Well, good to know.
Yep. So always attend the meeting.
So just looking at number 3, in the ANOVA hypothesis test, we reject the null when there's sufficient evidence to indicate at least one mean is different from the others. I'm pretty sure that's a true statement.
I guess are we discounting the like? I guess they're saying because like there's that one test where it's like if it's less than or equal to 4 times the variance, we're okay.
We're just looking at whether the mean is different than the others. We're not looking at the that part, right?
Yeah, I just thought because like the null hypothesis for the ANOVA test is that they're equal, and then the alternate hypothesis is that they're not equal or one's greater or less than the other.
Yeah.
So we're not worried about variance in that. Okay.
So I'm assuming that if you're rejecting the null, then one of them's different than the others because they're either not equal or one of them's greater than the other, which I guess by default, if they're not equal, obviously one of them has to be greater than the other. But anyways, I digress.
Okay.
And then 4, I put B and C.
B and C, yeah.
That is what I put as well.
Because I think, let's see, yeah, there we go.
Because there are 2 requirements in the book.
Yeah.
Yep. And then checking if each group is normally distributed. I'm pretty sure you have to construct the QQ plot for each group because that's what it talked about on the preparation assignment.
Yeah, that's what the book says.
Yeah, which is kind of aggravating because I thought that I could get through the rest of this course without really having to create any more graphs, but it looks like now we have to.
Oh, darn.
That's okay. I like work. And then number 6, we assume the variance in each group is the same if the following happens.
And that's what we were talking about a little bit ago.
Yeah, but the largest variance is less than 4 times the smallest variance.
That's what I think.
That number 7, I thought that one was kind of tricky because it says like
2.
We'll test every pair of samples.
There's 3 samples, there's 3 pairs. How many pairs are there when there's 4 samples?
I guess they're saying unique pairs.
Yeah, so isn't that interesting? So if there's 4 samples, like, would that be like you compare 1 and 2, 1 and 3, 1 and 4, 2 and 3, 2 and 4, and 4 and 3? Is it like talking about something like that?
Yeah, I wrote it out. I know that's silly, but I wrote it out.
That's what I was about to do, yeah.
Yeah,
So
that's not silly at all.
1 and 2, 1 and 3, 2 and 3, 2 and 4, 3 and 4, and 4 and 1. I have 1, 2, 3, 4, 5.
Do you have 6?
Yeah, 6. Does that sound right to you?
That's
1,
what I got when I wrote it out.
3,
Yeah.
4, 5, 6.
Yeah, 1 with 2, 1 with 3, 1 with 4. Yeah, so I get 6.
Well, I guess we'll give it a whirl and see if it's right.
How else would you figure out how many How else
Yeah, because in that example it says like there's 3 pairs, like it's just pairing up every single one with the others. So I'm pretty sure that's accurate.
Okay. Ooh, soccer shot.
I also
I
was
thought
kind of
that-
frustrated with the last homework quiz because like a lot of the data they put in there was pointless. Like they gave me the names of the athletes. I'm just like, really? Like I don't care. Like just give me their salaries.
I didn't even
And
look
then
at
like, hey, this. Yeah, I was just. I don't know. I thought it was really stupid. Maybe it matters to somebody. Okay. 5 times A, B, C, D, E.
Oh, where'd it go?
6 groups. 10 meters away. Turn.
This is gonna be fun.
Center. Okay.
So I got 27.208 for number 8.
Did you already fill all those in?
Well, yeah, I just copy and pasted all the numbers from the thing, the each different type of shoe, and the socks.
That was fast.
Yeah, I found that you can like split the screen between the 2 spreadsheets.
Mm-hmm.
So it made it a lot faster. I didn't have to be like switching between tabs and stuff. I found that in one of my classes.
Whoops. I overshot that one.
A. Do they want the socks data in there too?
Yeah, because in a later question it tells you to take it out. So initially, I think it's supposed to be in there.
Okay.
Ah,
Okay.
I like it when all I have to do is just do that whole line thing.
Yeah, so 27.208. What did you say you got, Todd?
What was that?
Did you got what did you say you had?
For the minimum
Oh.
variance, 27.208 was what I got for the minimum variance.
Yep. Okay.
And then the max, I'm just guessing, is that 53.158.
Yeah.
Are you doing all right, Susan? Are you?
53.158.
Yeah. Are you seeing that too?
Mm-hmm.
Cool.
1 to 10. That's for equal variances. So we have the highest. We have the lowest.
Yeah, I just multiply. So if you multiply the lowest by 4,
Mm-hmm.
and if that number is higher than the highest variance, then
Then we're good.
yeah, and I'm pretty sure that with this one it is, just even by eyeballing it.
So yeah, so
Yeah.
it's true. That's how you would answer that one.
Yeah.
Okay.
Oh,
Ooh,
yeah.
QQ plot.
Oh, jeez.
We can do
We have a
it.
50-50 of just getting it right. We could just guess, right?
That's what I was thinking.
That's a lot of.
That's a lot of stinking QQ plots.
Although this is recording, so we should probably do it.
Do you really think they watched it? No, I'm just kidding.
I'd rather not find out the hard way.
Yeah, we'll probably get like a nice comment or something in the discussion board, like "Don't appreciate your attitude" or something.
Yeah, right. Oh wow. It's normally distributed at all. That first one. Holy cow.
So is it like a scatter plot? Is that what it's asking for? Or
Are
how are you guys creating your?
you remembering to sort?
So do you like right click it and then sort?
Mm-hmm. Yeah,
And
otherwise
then
it's everywhere. No matter what data you put in there, if you don't sort it, smallest to
so you're supposed to sort smallest to largest.
largest. Okay, so variable 1 is normal.
Oh, whew, there we go. I was like, mother of mercy, what the heck?
I don't follow. I don't really remember how to make the graphs.
Sort smallest to largest. Number 2 is questionable.
Yeah, number 2 is the least normal so far. 3 is okay.
Oh, you're really doing well.
How are you guys creating the graphs to check it?
What's that called? The quantitative descriptive statistics Excel sheet.
Oh, so we're not using the quantitative inferences. We're using the other sheet.
Oh, yeah.
Oh, so you have to have the quantitative inference and the quantitative just descriptive, and you're just looking at the graph that one pulls up.
Yeah.
Mm-hmm.
Yeah.
So number 3 is close, but 2 is not so great.
And 6 kind of veers off the socks one, but I don't know if that matters. Veers off in like 2 different spots. It's also kind of a break there. I don't know.
5 is good. I'm sorry, 4 is good.
I wonder.
Five is good. Did you say 6 is different?
I mean, I'd say they're approximately normal for the most part. I mean, yeah, on that second one, they get kind of
a little bit off.
but
I think they're close. We don't have any crazy.
I think they're close enough.
Approximately normal. Yes, I think they're approximately
normal. Did you guys look at 12? I'm assuming it meant to say Excel.
Yeah.
See, this is how I was.
That again. Oh, okay, this is the one where we remove it.
Yeah, I got 0.309.
It's different, huh?
Yeah.
Not that one.
0.01, and then with socks. Wait, you got what? What did you say?
I said I got 0.309.
Oh, for some reason I thought you said 0.381. I was like, wait, what? No.
Yeah, that would forget.
Oh, that was, yeah.
I see the F value. I see the P value. Oh.
Interesting. p-value area to the right or left? What?
You get 0.309. Good.
Yeah, I'm pretty sure when from 13 that it's to the right, because they talk about it being right skewed, and that the p-value is like that little section where it like curves and tails off at the end.
Yeah. Yeah, I just remember looking at their diagram, and yeah, it was just saying it's right-tailed. It's just a question, Hudson.
Oh, are you on 13? F statistic. P-value area. Are you on 13?
Yeah.
So how did you read this one? Test statistics were opposite. I know they have p-value is to the right of the F, right?
Yeah.
Sorry, no more.
Hot dog nutrition.
I don't know why they would do a study on hot dog nutrition. They're all bad for you.
Yeah, there really is no such thing as a good one.
They taste good though.
Oh, yeah, very true.
Yeah. Okay, so we have to conduct the QQ plots for each one and assume if the. I feel like that's so.
Poultry. There's 3.
Yeah, I feel like that's so.
What do you feel like?
Like, is there like an easier way to create the QQ plots instead of using the other spreadsheet by just like highlighting the data and creating it in the same spreadsheet? You know, with like creating a chart.
Gosh, I don't know. That's a good question. I'm still erasing.
Did you highlight them all and delete it?
Oh, that would have been really smart. Silly me, I was doing it by column. Okay, so what are we comparing here?
We're comparing the calories for each.
Just the calories, not the sodium?
Yeah. For now, it's just the calories, it looks like.
All right.
I'm just getting frustrated because like it didn't used to do this yet. I don't know what's going on, but like I try and open up another Excel window and it just opens it up like in the same window. Like I don't know if you guys know what I mean. Like
I do. That happens to me at work, and I hate it.
So frustrating. And I'm like, no, I want a separate window so I can compare them side by side, and make it easier for data. But QQ plots for the calories of each 3 types. Oh my goodness. I like how there's a meat category.
Yeah.
What kind of meat, pray tell?
That's the great mystery.
Mystery meat.
Wait, how come
calories first?
there's less for meat?
Oh, you guys are so far ahead of me already. That's okay though.
So is it going to matter that like the poultry and meat ones have less data points?
I don't think so.
No, you can still see there
Oh no, I'm talking about for the
the QQ plot.
everything else.
No, because we've done the T2 test, and it didn't matter the amount.
Alright. Yeah, the beef one kind of veers off, I guess.
The which one? Beef one does?
Just a little bit, but oh, the meat one goes pretty far off too, actually. They're all about the same, I guess. They all kind of vary a little bit, but
Are they
they're all very good.
approximately normal, do you think?
Yeah, I would say.
So for number 14, then, are we saying that the are you guys thinking it's A, like the assumptions are met and the variances are equal? Because, and looking at all the different variances, like they're all pretty close together. So multiplying the lowest one, yeah, like, all right. So are you guys thinking that it's normally distributed with equal variances?
Yeah.
I feel like it wouldn't be asking us all these questions unless it was.
Okay.
Well, I mean, just looking at the QQ plots, like the only thing, I mean, I already pasted the data into the ANOVA test so I can look at the variances, and they're well within the 4 times rule.
Yeah.
But I don't know about looking. Are we able to look at a QQ plot and assume the variances are equal? Like, that doesn't seem like an assumption we can make to me, right?
Yeah, I feel like it's always good to just check it to be sure.
So did you guys?
Because I mean, like, the question is QQ plots, and then compare the variances. Oh no, it is saying look at the variances. Oh, okay. Then yeah, it is A.
It is A.
Yeah, because it does want you to look at the QQ plots and the variances. I thought it was saying just look at the QQ plots.
Yeah, because each one has like a 2 parts to it. It's like, yeah, the assumptions are met, and then you can assume equal variance. So
yeah.
Okay.
So for number 15, we've got
20 degrees of freedom are 2 and 51.
our p-value is definitely less than the A, than the level of significance.
Yeah.
So since the p-value is less than A, we're rejecting the null, which means that we have sufficient evidence that the mean calories are different then, right?
Absolutely.
So,
3 mean is really different too.
Right,
so
the null is that they're all equal.
yeah. So would that be C then? We have sufficient
Yeah,
evidence
this
to
one
claim. Would that be C?
I think it would be D. We have sufficient evidence to claim that at least one of the hot dog
Yes,
types.
it's D.
Yeah, I didn't read that carefully enough. Good call.
Yeah.
Because you don't know which one it is.
Mm-hmm. I mean, we can.
They could, like, 2 could be the same and 1 could be different, and thus it's still we reject the null, or all 3 could be different, but that's right, just to say that.
Sodium levels.
Yeah. Now do the
It's kind of like the way Todd suggested.
I what?
One. Oh, I was clearing it row by row instead of just highlighting the whole darn thing and getting rid of it.
Saves a lot of effort, doesn't it?
It kind of does.
All about working smarter, not harder.
Right.
You should see that the QQ plot for poultry suggests a possible problem with the normality assumption. The smallest variance is that, and the largest is that. Have the assumptions been met to use ANOVA? Well, if it tells you you're having a problem with the normality assumption, then wouldn't that tell you that the assumptions haven't been met to use it? Or am I just totally underthinking it?
The smallest variance, the largest is. They said the QQ plot for poultry. So do we need to actually look at it then?
I was just looking at the QQ plot for it, and I hit on that normal distribution line. But I mean, yeah, the variances still fit, but possible problem. Do not change the curvature.
Sorry, I'm a little slow,
Okay,
guys.
this is what the book says. It says we check this by creating a QQ plot for each group separately. If the points in the QQ plot do not show distinct curvature, it is reasonable to conclude that the data are normally distributed. I mean, yeah, I mean I don't. Part of it shows it like curving. You know that first part. If you look at the poultry, then like there's like a break, and then there's like more that follow it, but some of it's below. I don't know. It's like, I mean, there is an option where it says the assumptions have not been met, but what are the next
I
questions?
think it's a little off. Let's see.
Interesting. So it says, despite the problem, the next question, if you look, says, despite the problem with the QQ plot for poultry, you decide to use it anyway.
Yeah, so it's like, why do we even care?
So I think, honestly, I think it's C, is where it says the assumptions have not been met, because it says it's not safe to assume each group comes from a normally attributed, but we can't assume the variances are equal.
I think that's right, because when we were looking at the variances, the lowest one times 4 would be way higher than
the variances still fit, but where it's specifically telling us there's a potential problem. It's like, okay.
Yeah.
And then it's telling us to, despite the problem, use the ANOVA test anyway. Okay.
It's like, okay, if you say so. It's like, here's the rule. It's like, here's the rule, now break it.
They did that.
Don't follow the rule. Just
only use the rules when they're convenient. I got 0.17.
Well, and remember when they did that whole thing? It's like, well, for the margin of error, it's like, oh, use 2 times this, but the next chapter is like, just kidding, it's 1.96. It's like,
yes. You remember that?
But yes, I did get 0.179.
So because that is higher than our level of significance, we fail to reject the null.
I think it's
Yeah, so we don't have sufficient evidence to reject. Yep, we did it. 20 out of 20.
So for the last one, for question 18, you put B. We do not have sufficient evidence to reject the claim that all
Yeah.
say hot dog types have the same mean sodium levels. Okay.
Yeah.
All right, we did good.
Well done. Well done.
Wait, what did I?
Do you guys have any concerns about the homework, or not the homework, the exam so far, or hard to say? I mean, we haven't reviewed yet.
Yeah. It'll be nice to go through the review on Wednesday.
Okay. So has anybody
I
given
totally
any more
marked the wrong
thought
answer.
or- I'm sorry.
Oh no, I was just kind of talking to myself. I totally marked the wrong answer on question 3. I put false.
Uh-oh.
I really don't want to go back and do that for 1 point.
Yeah. You know how to leave that open and open a new window, right? That way you don't have to redo every problem.
Do you guys, were you going to ask Susan about the group project if we given any more thought to it?
Yes.
I think it'd be good to keep it simple. I think that idea that we had, just like polling people, see if they knew their blood type, just like poll people, like we want to find out how many people know their blood type, and then we can just go through and just kind of poll, and we can make it more, I guess, descriptive if you want to, because like on the survey we can have the thing where it's like male or female. Do you know your blood type? No. Like, yes. If you do, what is it? So that way, like, we have the data. So,
And then we can go from there and change it a little bit if we want to.
But I don't think we can do that because like we have to submit the design, the study, so we have to have a clear defined question that we're asking.
One thing I was thinking, instead, like, still do the if they know their blood type or not, but maybe instead of male or female, look at age groups instead. I don't know if that'd be more difficult, but I almost just based on my experience, I mean, where just in our little group, Todd's a little younger. He doesn't know his blood type. I think it's a more common thing, unless you've been in an emergency situation, to not know blood types for the younger generation. I'm kind of in the middle, where my parents are like heavy blood donors and all the time going to the blood banks and stuff, so they knew their blood type, and so when I could, I found out. But I think it'd be interesting, just from personal opinion, to see maybe if age groups would be an interesting thing to look at instead of just like male or female.
Well, we can definitely put that in there.
Yeah, the only thing I was thinking about that.
If you ask me any questions though, like you need to pick like only like 2 or 3, I think.
For what and plus, like, I think that's a good point. Like, I think older people generally would, but I just think, like, if I was going to go to the Crossroads and pull data, everyone's around the same age group as me anyways.
That's true.
Like, most of them are in that same situation that I am. Like, they're all around my age.
Yeah, so I guess that really wouldn't be as applicable then.
True. That would be it's a good idea.
Know, but I don't think it would be.
Right, he's got a limited kind of age group set already.
Yeah.
So maybe we test it like, do males or females know their blood type more often?
Oh, you guys kind of froze.
Oh, you're still coming through to us just fine.
Yeah, I took my video off, but can you guys still hear me?
Yeah, maybe I'll do that too. Maybe without video, it'll be a little bit better.
Huh. That's weird. It's like you guys go to like a like a robotic voice, real slow, and your picture freezes, and then I can't understand you. But.
I was saying maybe our test could be, do males or females know their blood type more often? So that way, like, we test like the male and, like, you know, talk to both genders, like, do you know what your blood type is? That way, like, it's a bit more interesting to where, like, we get data from a couple different sets and it's just finding out what their blood type is. You know, it's just like a nice simple study where you can compare, like, they're either the same or one of them clearly knows it more often than the other.
So it could be equal.
So would we really need to collect their blood type then? If we just say male or female, and then do you know your blood type or not?
Yeah, like, I guess, like, if that was our study, we wouldn't even have to collect what their blood type is.
Yeah,
we would just have to,
yes or no.
like, we would just have to ask them, like, hey, do you know what your blood type is? And then it's like yes or no, and it's a quick collection, but you can get a pretty large sample.
Yeah.
And it's a pretty easy test because you're actually testing something, like, you guys or girls know it more often, and then you can just compare the data.
I have a really good question. Is it going to be easy to know boys and girls where you're at?
Is it what?
Can you visually determine whether they're boys and girls? I know that sounds silly, but
I am on BYU Idaho campus, so
so it's a bad question, I know, but
no, it's fine. Yeah, I think I'm pretty comfortable in determining that.
Well, and if you wanted to avoid that, like, what
just
you
hand
would
just,
do,
just hand them the paper.
Just give them a little sheet of paper and just say mark, and don't give them the option for transgender or something.
I'm sorry. Yeah. I'm so sorry.
That's like opening up a whole nother can of worms. Yeah.
Come on, Susan.
I know. No, well, you know, I do live where I live, and it is kind of in the real world, and BYU is its own little awesome little environment.
We're quite sheltered here.
What a nice way to put it, Susan.
We are quite sheltered.
So, does that sound like a good experiment to you guys, or do you think
we should? I like it a lot.
So I guess to kind of just brainstorm, what would like a null hypothesis be? Like
equal.
Equal number of male and female know their blood type, and an alternative hypothesis would be like
guys would know it more than girls, or girls know it more than guys, or they're not equal.
It'd probably be easier to do, not equal the hypothesis test.
Not equal.
I mean, it doesn't necessarily give us any conclusive information, but that would be probably for, if we wanted to continue the study, we would then look at, who knew more or not. But yeah, so I think that it'd be pretty limiting to assume, like, it would be from a data technical standpoint, it would not help us to say our alternative hypothesis is, males or females know more than the other gender, because then if neither is true, then technically speaking, even though we've got the data to say, more males knew or more females knew, according to our hypothesis, we're screwed. So the two-tailed that not equal is probably the best one.
What is your guess right now?
My guess would be that it's about the same.
Your guess
I would actually think it'd be more female oriented.
So do I.
Just because of like detail oriented, like, females tend to be detail oriented, and then like just from my experience, like with my family, not just my immediate family, but my extended family, just with the amount of I don't want to call them medical procedures, but just typical things that are involved with a female, I would assume the chances for a female to know blood type would be higher than a guy. But
yeah, that's the only thing I'm thinking of.
Other than that, who knows?
Because I think with your young population, even on BYU campus, we do have parents They might just be single, they may be married, but we also have parents too. And I think that the women need to know their blood type for their pregnancies. Does that make sense? That whole RH factor thing?
Yeah, I suppose it does, yeah.
But again, how many of your population have kids that are women? I don't know.
Well, the thing is, like, I see a pretty good cross section, like, because I go all over campus. Like, I go to the ice center for my soccer games, and there's like married women pushing their strollers around the track. You know, I see people with strollers in the crossroads. It just kind of depends on what times you're there, but if I feel like I could get a pretty good cross section of people representing.
That's
all.
awesome.
Yeah, and plus I could even take it to work with me because there's a whole bunch of people there that are. Some of them have kids, some of them don't, some of them are married, some of them aren't. So I feel like I have a lot of people I can talk to.
Okay. So I think we're kind of decided that we're just going to do male or female, and then if they know their blood type.
Yeah.
And what type of hypothesis test did you think we would do?
The two-tailed, the not equals.
Okay, cool. Well, we're a little bit more planned. When is this actually due? Do you guys remember? I mean, I can look it up, but
it's due in certain parts. I think the first part of the design of the study is due in like a few weeks.
okay.
But don't quote me on that.
This is women two-tailed, not equal. Okay, cool.
Oh, dang it.
Well, then, are we good for the night?
I think
I'm
so.
good if you guys are.
I'm great.
Let me stop recording.